Hi, everyone. I'd like to talk to you today about something we've been working on for the past couple of years at Mozilla to really help improve the security of our web applications and our web services. And so in this talk, I'm going to talk about issues we've seen in web application and web services and how we managed to reduce these issues and the number of these issues using DevOps techniques and integrating with DevOps techniques. But first of all, I'd like to start with something that really makes me sad. And what makes me sad is Tuesday morning. And for most people, it's Monday. For me, it's Tuesday. And Tuesday morning makes me sad for a number of reasons. The first one is my first meeting on Tuesday is at 8 a.m., and that's way too close to my first cup of coffee. The second reason is Tuesday is my day, my turn to do the bug bounty triage of Mozilla. And that usually means I'm going to spend a significant part of my day reading bug bounty reports. And a lot of bug bounty reports go like this. I have found a source code disclosure on mozilla.org, right-click view source, and you can steal all our source code of the server. This is a major vulnerability. Can I have a bounty now, please? So we realize that a number of bug bounty reporters are junior, and they're learning, so we try to be nice to them. Dear security researcher, we appreciate your participation to Mozilla's bug bounty program. However, this is not a vulnerability, but simply a feature of the web, and thus not available for a bounty reward. Why don't you pay a bounty? It's a major vulnerability. I hacked the NSA with it. You must pay me a bounty. Or a T-shirt. Can I have a T-shirt? April is in the audience, and she knows what I'm talking about. But that's not why I'm sad on Tuesday. On Tuesdays, I'm sad because once in a while, we get a report like this one. And this is a legitimate report that we got about a month ago of a cross-site scripting vulnerability in hg.mozilla.org. And hg.mozilla.org is where we keep the source code of Firefox. That's a public web UI that lets people view that source code in a browser. And this cross-site scripting vulnerability uses a query string injection to run JavaScript in your browser. That's a reflected XSS. And that's bad, obviously, because not only can you steal stuff from hg.mozilla.org, but also from the entire mozilla.org domain. So we don't like those, and they make me sad. And the fundamental problem we have here when we see one of those is that we, as security teams, have failed to protect our web applications before they go to production. We've actually shipped code that runs in production that is vulnerable to attacks. And that really is what makes me sad. We get a lot of these issues. This is bug bounty statistics from last year. We get all sorts of bug bounty reports. Not only we see web vulnerabilities on all sorts of things. So you get session issues, you get SQL injection, the occasional crypto vulnerability, account misuse, et cetera, But the green bar that goes all the way to the right here is cross-site scripting attacks. And you can see how many of those we get in comparison to all the others. So we spend a lot of time triaging those cross-site scripting attacks. We've solved that problem a while ago, right? Put content security policy on your site and you're done. Yet we're spending a significant amount of time essentially triaging bug bounty reports that tell us that our sites are vulnerable to XSS. It costs us money, too. The average bounty payment is $2,400, and we only pay on high and critical issues. We don't pay for the low and moderate issues. And we also only pay on a subset of our sites, not all of our sites. But when we put that together, at the end of the year, we almost spent the cost of a full-time employee just playing whack-a-mole with things we should have fixed long ago. So we're wasting money. And so the question here is, can we increase application security by finding these issues before they reach our production systems? So we don't have to spend time triaging bug bounty reports after the fact, and we can actually spend time increasing security. And here I'd like to take a little bit of a detour and talk about DevOps. And a lot has been said about DevOps, and there are a lot of buzzwords about what it is, what it isn't, the unicorns and how magical it is going to save your entire infrastructure, et cetera, But fundamentally, DevOps is about three things. First of all, it's about rapid release cycles. It's about releasing your software more often, so you don't send a massive patch to your production system that's going to change probably 20 or 30 or 40 different features. No, you send patches often. You release every day, multiple times a day, and every time you release, you just have a few changes so you can verify that the changes are implemented correctly and don't introduce regressions. The second thing of DevOps is global automation of integration and delivery pipelines. In order to deploy that often, you need to have automation of everything. You don't want any manual tasks. You don't want a sysadmin to have to package an RPM of your application and manually copy it over to a server to deploy it to 10 different machines. That doesn't work in DevOps. You need to go faster and automate all of that stuff. And the third one that I think is probably the most important and often the least regarded in DevOps is the close collaboration between teams. In a DevOps organization, you don't want to have departments of developers and operators and QA and security and project managers, et cetera, that don't talk to each other. That doesn't work. In a good DevOps environment, you have a product team, and that product team is focused on building a product and making a great quality product. So you will take 2 developers from the department of developers, and you will take 1 ops and 1 security, 1 QA, and 1 project manager. You put them together in a room and you say, build me a product. And you may not belong to the same departments, but now you're a product team and you work together. And that collaboration aspect is important. So what is a DevOps pipeline? Well, at Mozilla, at least Mozilla Services, DevOps pipeline looks like this. You have a developer on the left who will be writing a patch and putting it on GitHub. And when that happens, another developer will review that patch. And at the same time, a number of tests will run in a CI environment, whether it's Circle CI, Travis CI. We have our own internally called Task Cluster. There are a number of those. And those tests give you feedback on the quality of the patch. And at the same time, the manual code review will tell you if the patch is appropriate. And what is okay, when that's okay, you just merge it into master, and then we'll build a Docker container, also in CI, that's also automated, and push it to something like Docker Hub. On the infrastructure side of this, you want to deploy a new stack. So you're going to take a bunch of code that will generate or create new servers in AWS, new databases, new security groups, new load balancer, et cetera. And you automate that through something like Jenkins. And once your stack is ready, you will put your Docker container on top of it, and that entire step of deployment is automated. Now, there are very few manual steps here. Of course, the developer needs to write the code, and a peer needs to review it. And maybe an operator will click a button to trigger the deployment, but everything else in that pipeline is automated. And the question is, can we integrate security testing directly inside of the DevOps pipeline? Can we actually test our applications to make sure they don't have all of these issues that translate into bug bounty reports and vulnerability to our users? And can we test for that directly in the pipeline? And that is what we call test-driven security. And the way we implemented this at Mozilla is in 5 steps. The first step is define a baseline. What are you requiring your applications to implement? What are the controls you care about? It may change from organizations to organizations, but you need to define what is this minimum set of requirements that you want everyone to implement. And then you need to write tests for them, because you want these requirements to be tested automatically. You don't want to do it manually. And then you need to run these tests in a CI/CD environment. The 4th step is really probably one of the most important ones. You want to work with the developers and the operators to socialize these requirements, to make sure they understand them and they're ready to implement them and own them. And finally, when you've done all that, you can actually require that the test pass to deploy your application to production. Seems pretty simple, right? So let's see how we actually do this. This is a screenshot of the Mozilla Observatory. And it shows you a list of the HTTP controls that we consider to be requirements to ship anything in a production environment. So it's not a complete list of all the controls we require. Those focus really on the web layer, the HTTP layer. But you can see the first one is content security policy. We want all of our website and web APIs to have a CSP. We also want things like HTTP public key pinning. If you're doing HTTPS, you must be doing HTTPS, and strict transport security. And we have some more sophisticated things that most sites should be implementing depending on the use case, like sub-resource integrity, et cetera. The point here is we didn't just come up with these requirements and went to the devs and said, now you must do this. It's 2016. This is your new set of requirements. We actually worked with them. We went to talk to the devs, and we said, how do you build applications today? What is important to you today? And can we put that into a standard and improve that standard over time? So there is an important aspect here that we're not just building compliance, we're actually improving the security of web applications by working with the devs and defining that baseline security. Once we have that, we can write tests. And we use a number of tools to write and run this test. So obviously, the Mozilla Observatory is one of them. We use the OWASP Z-Attack proxy, and we write a lot of our tests around ZAP. Other tools, if you write Node.js services, the Node Security Project NSP is a good one. If you're using Python, you have requires.io and similar services, et cetera. ESLint is another good tool to lint your JavaScript. So we write all of our tests into these testing platforms so we can then run them into a CI/CD environment. So here we're focusing on the green box, the one that's really right at the pull request level. And we want to run our test there. So in a pull request, when you send your code for review, automatically a webhook will be triggered. And for example, we ask Circle CI to run a whole bunch of tests that are configurable on this new code. And what we did here, this is standard practices. Developers have been using tools like this for years, and they work great for them because it gives them early feedback, and it gives them a way to run their unit tests and their integration tests automatically at every code change. So we wanted to run our tests as part of this process as well. So we took ZAP, the Z-Attack proxy, and we packaged it in a way that could actually run in a CI environment. And here, for example, we will run, this is a sample of a Circle CI configuration file in YAML. And we have an application here that's called QtFox that has been packaged into a Docker container. And we run that application with Docker run Mozilla QtFox. And at that point, inside of your CI environment, you have an instance of the application that is running inside the CI server itself, and that is listening on a local IP and local port. It's not accessible from the outside, and it's very ephemeral. It's just running for a short period of time, but we can scan it. So we pull down the Docker container of ZAP, and we run a scan directly against that local application. And what that does is, within the pull request, when we run CI, we will do security testing of the application that isn't anywhere close to production, that isn't even in staging or anything like that. It's a pull request. And the output of that scanner is what we see here. You will have the first 3 lines show test that passed. So this application correctly said strict transport security, does not have any issue with CSRF, all the tokens are set correctly, and does not have any mixed content. And we talked this morning about how important that is. But we have 2 failures here. The first one is that the cross-site scripting protection is missing, so the CSP policy is probably not in place. And the second one is that cookies don't have the same site attribute. And we also give developers the location of these resources directly in their application so they can go and look at the routes of these resources and see why the headers are missing. If a test fails, the ZAP scanner simply returns a non-zero error code, and that will just fail the Circle CI build and return a non-satisfying status to the pull request saying that it shouldn't be merged. So obviously, we can't just take a whole bunch of tests and go in and break the CI environments of all of our projects without first talking to the developers. And in a lot of cases, we can't simply just enable everything on day one. So we need to socialize these requirements. The URL at the bottom of this slide links to a checklist we wrote. And this is a checklist of all of the things we ask developers to implement. It's in Markdown format, so it's very easy to put it on a project. And it's very easy for developers to read through it. It's not very long. It has a lot of items in it, but you can really skim through it in less than a minute. And it very clearly tells developers and operators about the kind of controls we want them to implement when they want to go live. So there is really no surprise here. They know what we're going to ask them to do. And finally, when we have done all of this, and everybody's happy with the test, and everybody knows what is expected of them, we need to require this test to pass before we go live. And here we're on the second box, the one on the right, the orange one, where we will run this test again, this time in our continuous deployment infrastructure. If you've never seen one, this is a Jenkins pipeline. What a pipeline is, it's a set of steps that are taken by the Jenkins infrastructure to deploy or to just run through the infrastructure deployment code. So in this case, the first build step will create a new set of servers for the new service. So we're generally an immutable infrastructure, so we don't reuse servers, we create new ones for the new version of the stack. And we will deploy the code or the new Docker container to this new infrastructure. And once we have that, essentially we have an infrastructure that is almost ready to go, but we haven't validated it yet. And that's where the ZAP scan comes in. We will test that staging infrastructure and make sure it's up to standard, the same way we tested it in CI and we verify it again in CD. Once we've done that, and if the test passed, then we can go to the next phase, which is usually to promote that stack as a new staging or production stack. There are a few gotchas with this approach. You don't want to frustrate developers, you don't want to frustrate ops. So what we do here is we run these against staging environments only. We don't run them against production environment. And the reason for that is, first of all, we have run into security incidents where we needed to quickly redeploy production stacks, bypassing most of our controls. It's emergency situations where you essentially say, we have to, within the next 3 minutes, redeploy a stack with this new code running. And so we don't want to block a production deploy on a ZAP scan or something like that. But staging is fair game. So when you run through staging, you need to be up to standard. And in 99% of cases, the same code that's run through staging will be running through production. So we guarantee by testing staging that we have a clean stack in production. On the right side of this slide, you see a little code snippet which we use to automatically enable ZAP scans in our Jenkins templates. So essentially, every time the ops will create a new Jenkins template, they will just have that little code snippet in there, and it will automatically require a ZAP scan in the stack. So we don't have to manually go in and make sure that every deployment uses our logic. It is part of the templated deployment infrastructure. Does it work? Well, baseline security does work. These are the stats for addons.mozilla.org, and those bugs are now public. And AMO is an old site. It was created in the mid-2000. And between 2010 and 2015, we've had over 106 bugs, out of which 63 of them were cross-site scripting attacks. That's a lot. We spent a lot of time mitigating those. And we knew when we started this exercise that AMO was one of the sites that needed CSP the most. So in 2016, we enabled content security policy and a number of other things on AMO. And right away, we saw the number of cross-site scripting attacks drop significantly. As soon as we put CSP in place, no more XSS. It doesn't fix all issues. We still see bugs, and that's an important thing. Baseline security is about getting you there, but you will still have to fix all of these complex issues that might come into complex web applications or complex products. So it's not about fixing all of the security. It's about fixing the baseline, so you can focus on more complex things. In summary, if you want secure application, you have to stop playing whack-a-mole with stupid issues. You have to focus on the complex ones. And the way you do that is first by defining the baseline of your security, making sure that you can drive the testing of that security directly inside of your DevOps pipeline. Make it part of the product. Don't run a security infrastructure on the side when you have a pipeline that developers run through multiple times a day. Integrate into that pipeline and become part of the DevOps team. Never deploy substandard code. Make sure that every time you deploy something to production, it has all of these controls in place. And it shouldn't even involve you. As security engineer, you should be involved with writing the test. You shouldn't be involved with running the test. That's the job of DevOps. And when you do that, you actually save time to work on much more complex things that security teams should be specialized on. And in the next few talks, David and Nestor are going to talk about complex techniques to fuzz your applications and to test really deep inside the code for vulnerabilities in your applications. And that's what security teams should be doing. The simple type of controls that you can fix with baseline security should be automated into your pipeline, and you shouldn't have to worry about it. Thank you very much.